depend upon magnets and magnetism. The irregular light in the sky are called northern lights or aurora borealis. They are caused by Earth's magnetic attraction. For electrically charged particle given off by the sun, when particle collides with gas molecule in Earth's atmosphere, the molecule gives off light. Same thing also occurs in the southern hemisphere, when the lights are called southern lights or australs. Northern and southern lights are visible mainly near the poles, and they are typically green. A magnetic force can cause such spectacular effects, and why Earth is a giant magnet. The futuristic-looking trains called the maglev train. The word maglev stands for magnetic levitation. Magnets push the train upward so it hovers or levitates above the track without actually touching it. This eliminates most of the friction acting against the train when it moves. Other magnets pull the train forward along the track. Because of these magnets, the train can go very fast, can fly over the countryside at speed about it can fly over the countryside speed up to 480 kilometers, 300 miles per hour. What are magnets and how do they exert such force? What's the properties of magnets? A magnet is an object that attracts certain material, such as iron. The magnet has north and south poles. Attracts objects such as paper clip contain iron. What is magnetic poles? All magnets have two magnetic poles. Poles are a region where the magnet is the strongest. The poles are a region when the magnet is the strongest. Poles are called north and south because they always line up with Earth's north-south axis. The magnet is allowed to move freely. Earth's axis is an imaginary line around which the planet rotates. What do you suppose would happen if you cut the magnet in half along the line between the north and south poles? Both halves would have north and south poles. If you cut each of the halves in half, all these pieces would have north and south poles as well. Piece of a magnet always have both north and south poles, no matter how many times you cut the magnet. With magnetic force, a force that the magnet exerts, such material is called magnetic force. Like electric force, magnetic force is exerted over distance. It includes forces of attraction and repulsion. North and south poles of two magnets attract each other, while two north poles or two south poles repel each other. What's a magnetic field? Like the electric field that surrounds a charged particle, a magnetic field surrounds a magnet. This is the area around the magnet where it exerts magnetic force. It shows a magnetic field surrounding a magnet. Tiny bits of iron, called iron filings, are placed under a sheet of glass. When the magnet was placed on the glass, tracked on the iron filings. The pattern of the iron filings shows the lines of force mixed up the magnetic fields of the magnet. Concentration of iron filling in the pole indicates this area exerts the stronger force. When two magnets are brought close together, their magnetic fields interact. Drawing shows how line force of north and south pole track each other, whereas these two north poles repel each other. The relation between magnetism and materials. Magnetism is the ability of a material to be attracted by magnets and to act as a magnet. No doubt you will handle with refrigerator magnets. Refrigerator magnets get to a refrigerator door because it contains iron. Probably know firsthand that they stick to a refrigerator but not to surface such as wooden doors and glass windows. Wood and glass are attracted to a magnet, whereas the steel refrigerator is. Obviously, only a certain material responds to magnetic force. What makes material magnetism is due to the movement of electron within the atom. A matter when electron spins around the nucleus of an atom, it causes the atom to become a tiny magnet. It's north and south pole and the magnetic field. In most materials, electrons orbiting the nuclei of atoms are arranged in such a way that material have no magnetic properties. Also, in most types of matter, the north and south pole atom point in all different directions. So overall, the matter is non-magnetic. Examples of non-magnetic material include wood, glass, plastic, paper, copper, aluminum. These materials are not attracted to magnets, cannot become magnets. In other materials, electron field orbitals of the atoms that make some material in a way to allow for each atom to have a tiny magnetic field, give each atom a tiny north and south pole at large areas, where north and south pole atoms are lined up in the same direction. This area are called magnetic domains. Generally, the magnetic domains point in different directions. The materials are not magnetic. However, the material can be magnetized by placing it in a magnetic field. This happens, all the magnetic domain become aligned and the material becomes a magnet. Material that can be magnetized are called ferromagnetic material, include iron, cobalt, and nickel. Temporary magnets and permanent magnets. Materials that have been magnetized become temporary or permanent magnets. If you bring a bar magnet close to a paper clip will become temporarily magnetized as all their magnetic domains align. As a result, the paper clip will stick to the magnets, also to each other, and when we remove the paper clip from the magnet's magnetic field, their magnetic domain will no longer align. As a result, the paper clip will no longer be magnetized, will stick together. If you drill an iron nail with a bar magnet, the nail will become a permanent or at least a long-lasting magnet. The magnetic domain will remain aligned even after you remove it from the magnetic field of a bar magnet. However, their magnet can be demagnetized when they are dropped from heat to high temperatures. This action removes the magnetic domains out of alignment. Some materials are natural permanent magnets. The most magnetic material in nature is called the mineral magnet, also called the lodestone. The magnetic domain of naturally aligned with Earth's axis. The magnetic property of magnetite have been recognized for thousands of years. Earliest compacts used to magnetite pointer to show direction. The magnetite spoon compass dates back about 2,000 years, come from China. Having a summary, magnetism is an object that attracts certain materials such as the iron. All magnets have two magnetic poles and a magnetic field of which they exert force. Opposite magnetic poles attract each other, and like magnetic poles repel each other. Magnetism is the ability to be attracted by a magnet and to act as a magnet. Only from magnetic material having this property include iron, cobalt, and nickel. And these materials are magnetized, they become temporary or permanent magnets. Magnetite is a natural permanent magnet. That's it. Thank you very much. I'm G major scale, A minor scale, to Mozart, Allegro Brilliant, and Haydn concerto in G major. enjoyed.